Hello, everybody. This is going to be a quick video about how our parameters for, let me just add a new notebook here, um, how the parameters of our power function, f of x equals kx to the p, how the parameters p and k affect the shape of the power function. So let's think about that. In the past, right, so for linear functions, um, there were kind of two options for m, right? Either it went up, right, or it went down. And, oops, you should give me a dotted line here, guys. What happened? Um, anyway, and then, so this is, m, oops. So this is like m greater than 0. Um, here we have m less than 0 for decreasing. And then we had that one other parameter. So this would be y equals mx plus b. So that's what b does, right? Is it steeper or shallower? Is it increasing or decreasing? What does b do? Moves us up and down, um, moves our y-intercept up and down, the point where we cross the y-axis, the x equals 0 point, if you will, up and down, right? Doesn't change the slope, doesn't change much else, just moves us up and down with the same slope. Yeah, so that's the effect of m and b in a linear equation. And then we talked about for exponential equations. So here we have a form y equals ca to the t. Some people write it pe to the rt. And we talked about how you could solve for e to the r as the a there. Yeah, so, and what were the shapes we could get out of this? We could decrease, we could increase, and then we could make c negative. And what would that do? That would make our decreasing function an increasing but not crossing 0, not crossing y equals 0 function. And it would take this one, right, and flip us up this way. And I'm sorry, guys, I've drawn this just a little bit inaccurately there. That would look more like that. That would look more like that. There we go. Yeah, so these are for c less than 0, and these are for c greater than 0. These two right here, let me outline them in a different color. Right, these two right here correspond to a, well, a between 0 and 1, right? Let me write a little, give me a little more room there. 0, not greater than 0, strictly less than 1. We get these decreasing exponentials, right? Oh, let's just outline the increasers. So there's the increasings, and kind of the negative c version of that is a steeply decreasing function, right? And so those are for a is greater than 1. So c negative, a is greater than 1, you get this. C positive, a greater than 1, you get that. And similar pattern happening here with the a between 0 and 1. Okay, so that's kind of what we've done so far. And what we found in class lately is that power functions are a little more flexible. So what are the options we have, right, for power functions? We could have a p greater than 0, right? we can have p less than 0. So this is y equals kx to the p. Let's make that look something like a k, shall we? Yeah, y equals kx to the p. But we've discovered that this isn't quite the whole story, right? When p looks like a square root, so or a 1/2 power, I should say. So if we have a y equals k root x, we've seen that that looks a little bit different, and that even looks different from like the third root of x. There are slight differences in those. So, well, the easiest way to examine these differences is to just freaking examine them, right? So I've written kind of every useful permutation I can think of, right? I think we might add one at the very end, but here's the story. Um, so look at this for a second. How is it that I'm getting odds and evens out of all this using that one variable p? Um, yeah. Extra credit if you can tell me why, say, this one will always give me an odd power. Okay, so, well, here we go. So this is, and this is sort of like the extra credit assignment I showed you guys. So one of the things I said in that assignment is that you had to label things. And here's how you label things in Desmos. I've got a label box, and say I want to label this guy. I just hold the label button over here on the side, the label tab I'm moving up and down. I grab the kind of quotation mark there, and I can move it up and down in order. And I can type into it, say, P, let's do a lowercase p, positive, and even. Okay, what does that look like? Turn on that plot. That's your quintessential parabola, right? And even though p is 1, I'm using 2p, so that's an x squared function, right? I can move that up, right? And every time I move up a whole number, it's still a p function. In fact, I'm going to make the step on this guy 1. So what I did there was I went settings, and it's got this increments for p thing going on, right? I said make the step 1. So now it's going to jump even powers. And what happens? Let's zoom in here on the origin. Even powers have a very similar shape, but it gets flatter and steeper at the sides, right? Steeper, I'm not really sure how to point here, but if you look sort of towards 1 and -1 on your graph, you see the bigger p gets, the steeper it bends. Yep. And if p is 0, we get a flat line. That's really not a surprise. Now, well, geez. Well, I'll keep them because it'll be fun later. And you notice I didn't need, say, this graph, right? Because I can just make p negative. And now we're getting that shape we looked at in class, right? Even powers, we have a symmetry about the y-axis. And again, we see that kind of increasing steepness, though in this case, the bend is coming from the opposite direction, right? Okay, so we'll keep p at 1 there. So that's, what is that? That's even positive powers and even negative powers. And you can proceed. This one will always get me an odd power if I'm going p in increments of 1. It always does. Yeah, for extra credit, prove to me why. So let's see what's happening here. First, we can kind of zoom in, and you can see that cubic sort of is shallower when numbers are less than 1 and is much steeper when numbers are greater than 1. And we ranked powers today in class, and that's kind of one of the things we came up with. So that's a way to do that. And so I've just gone through the cases here. What if it's an even fraction? I get something like a square root. What if it's an odd fraction? I get something like a square root, but it's got a tail. It's got a tail to the left instead of as well as to the right, right? And this comes from well, let's think about this, right? The square root of -1 is undefined, right? But the cubed root, or -1 to the power of 1/3, is defined, right? And so you're seeing that in the graph here. My red line stops at 0 because I can't put negative numbers into that function. The domain is restricted by the properties of the function. But a cubed root will produce negative results, right? It's okay to plug a negative number into a cubed root, and what you get out is a reasonable thing, is also a negative number. So you have this symmetry, not about the y-axis, not from -2 to 2 on the x-axis, say, but you have it sort of across the corner, right? If I folded this lengthwise and then folded it, so folded it like side to side, and then folded it up to down, right? I would have this line, the left part, or the right part of the blue line would overlap the left part of the blue line here. So for example, if I switched this, if I folded across the y-axis here, this line would now be like over here. Can I do that? Well, I'm not going to get too into it, but I would fold that line. I do a mirror symmetry. If I folded across the x-axis too, I would match up the right side of this with the left side of this. So that's what we call an axis symmetry. It's symmetrical about the origin, I should say. It's an origin symmetry. Whereas, and that's kind of a different symmetry than what we saw with, say, our negative even powers, right? There we have symmetry about the y-axis. If I take a negative odd power, symmetry about the origin. Symmetry about the y-axis, symmetry about the origin. All right. Now, the real cool thing you can do if you set up all your functions as a P kind of deal here, right? Wow, that's complicated. Look at all that beautiful function stuff going on. Well, I'll get rid of these. Let's just go here and hit this play button. Whoa. 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 Now they're only going by integers, so it's a little weird looking, but let's fix that. 0.01, say. Let's move this, let's make this thing move, right? I could go like -100 to 100. I could say I'm done with that. You know, one thing I don't like is there's no k's in this thing. Let's go ahead and investigate a little bit of what k does while we're at it. Just throw a k in every single one of these. Won't take long, right? Now it's like, okay, what do you want k to be? Well, I do want to add a slider for k. I'm going to go into the settings and monkey with it a little bit. I'm just going to make k between -1 and 1. Right? Those are the things we really care about. Small step there. And what this is going to do, so let me just show you what happens for one function. I'll turn all these back on in a second. Okay, right? K is 1. We got that, right? Now what happens here? I'm going to decrease the value of k. And it looks like these are kind of bending in, right? And that is what happens, right? K is multiplying this function and kind of shrinking it. Um, if I turned on, if I made this a positive, right, we might be able to see it a little bit better. Let's make it a small positive, like a